So good afternoon everybody. Myself Acharya Vishvendra. Let's discuss NCRT line to line questions. And the current chapter is chapter number 6, which is work power energy. So let's start discussing this. So initially we have questions on the form of energy, and what is energy, then which are vectors and scalars, then we have a scalar product, conditions for maxima and minima, then we have magnitude of dot product, the conditions for which these are maximum and minimum, then we have some numericals based on dot product, then properties of dot product, then we have some unit vectors, then we have a dot b, then we have a numerical based on two vectors and their dot product, then we have conditions for perpendicular vectors, then dot product zero conditions, then we have a question based on two vectors, and we need to find the magnitude of two vectors, then their addition, magnitude, scalar product, angle, projection, vector projection. Then we have another numerical question. We are being given two vectors. We need to find the dot product of the vectors. Then we need to find the angle between vectors. Then we need to find projection of vector P along vector Q. Then projection of Q along P. Then we have a question based on vector projection. Then we have work energy theorem. Then we have some questions on kinetic energy. Then we have a numerical problem based on time taken. Then on work done. Then speed of rain. Then work done by friction. Then we have certain questions on kinetic energy, work done by forces. Then we have a numerical based on a force displacement, and we need to find the work done by the force. Then we have questions on SI and CGS unit of work. Then we have a question based on pushing of wall. Then we have a numerical based on weight holders. Then we have work done in slow movement. Then we have a block problem. Then we have a question on work done by gravity. Then we have work done by gravity on moon. Then we have a question on definition of work done. Then conditions for positive, negative and zero work done. Then conditions for maximum and minimum work done. Then dimensional formula of kinetic energy, work, then SI unit, then CGS unit. Then we need to find ratio, then relation between electron volt and joule, then calorie, then kilowatt hour. Then we have a question based on work done by cyclist on a road and vice versa. Then we need to find acceleration of cyclist, then kinetic energy of cyclist, then speed of cyclist, then the time after which cyclist will stop, and we need to choose the correct option. Then we need to find the kinetic energy of a body. Then we need to find a question based on police officer, and we need to find initial momentum, initial kinetic energy, final kinetic energy, final speed, losing kinetic energy, work done by plywood on the bullet. Then we have a question based on variable force. We need to find work done during x1 to x2. Then we have been given the function of force as x plus 2, and we need to find work done from 1 to 2. Then we change the function to e raised to power x, and we need to find the work. Then we have a graph based question. We are being given the graph of force versus displacement, and we need to find the work done during different intervals, initially from 0 to 5, then 5 to 10, then 10 to 20, then 0 to 20. And again there is another question based on force and displacement, and we need to find work done during 0 to 2. Then we need to find work done during 2 to 4, then from 4 to 8, then from 0 to 10. Then we have another question based on force position graph. We need to find initial acceleration, kinetic energy, speed, momentum, impulse. Then we have a variable force problem, and we need to find force at origin, acceleration, work done, kinetic energy. Then we need to find speed of block at x is equal to 4. Then we have earthquake, string, fault lines. Then we have gravitation potential energy. Then we have just before striking speed. Then we have potential energy, relation between force and potential energy. Then we have a numerical based on potential energy. We need to find potential energy at origin. Then graph of potential energy, then force acting on the particle. And then we have a question based on force. And we are being asked force at origin. We need to find its acceleration, work done, potential energy at a given position. Then we have a ladder based problem. Need to find the speed at A at a point B. Then we have a question based on angle and the speed. Then we have dimensional formula, SI unit, CGS unit, relation between force and potential energy, work energy theorem, mechanical energy, conservative forces, law of conservation of mechanical energy. We need to find there is a numerical based on that, and we need to find its acceleration, speed, kinetic energy, potential energy. Then we have a problem based on circular motion. We need to find the minimum speed for completing the circle, then for oscillations. Then we need to find tension at different points, then speed at different points. Then we are being asked about spring force, dimensional formula for that, spring constant, graph between force and position. Then we have potential energy of a spring mass system. Then we have some numericals based on the graphs. Then we have mass block system and various problems based on the graph. Then we have maximum displacement. Then there are certain questions on friction, then work done against friction, then the concept of chemical energy, then electrical energy, nuclear fuels. Then we have energy required to break bonds of DNA. Then we have concept of power, SI unit, instantaneous value, initial value. Then we have a question based on acceleration, force, tension, power, etc. Then we have certain concept of collision. Then we have concept of elastic, inelastic collision. And then we have some problems based on finding velocities, loss in kinetic energy. Then we have conditions for elastic and perfectly inelastic collision, loss in kinetic energy. Then we have maximum transfer of kinetic energy. Then we have certain questions based on oblique collisions, and then it's last we have conditions for collision. So in total there are 201 questions. So I think these will prove to be a boon to you and can prepare you up to JEE in physics, and you can score better in your physics and make your concepts crystal clear. Thank you and have a nice day.